Okay, today we're going to talk about protists and fungi, and I've decided, because we're rapidly running out of time, it's towards the end of April already. May is just a little more than a week away, and that means the end of school is only about 3 to 4 weeks away. So we just don't have time to do everything I would like to do. So here's how we're going to do this. We're going to spend 2 days talking about protists and fungi. It's kind of going to be interwoven. It's not going to be protists one day and fungi one day. It's going to be both of them back and forth. But the way I've set this up is there's two videos today that you're going to watch that are the one's an Amoeba Sisters, and then one is a SciShow video. Those are longer, and you have questions to answer about those. Then there are 2 very short videos, between 30 and 45 seconds each, that give you examples of things that were talked about in those videos. So I want you to watch those. The short clips, there are no questions to answer. The SciShow video about slime mold has a question set, and then the Amoeba Sisters on protists and fungi has a question set. The reason I wanted to talk to you through video today before you start your lesson is because the order is all messed up, and I can't really figure out. Google's not letting me get it in the order I want to for some reason. So I wanted to just make sure you understand the assignment clearly, and then also just kind of give you a really brief overview of both protists and fungi. Protist tends to be, the kingdom Protista tends to be the dumping ground, at least it seems that way, because there's so much variety, and it's almost like it seems scientists, if they can't figure out if it's a plant, an animal, or bacteria, then it's going to get dumped in kingdom Protista. And the reason it seems that way is because there's so much variety. I mean, some are heterotrophic, some are autotrophic, some are both, meaning they can photosynthesize, but they don't have to photosynthesize because they can also eat something else to get energy. Some are unicellular, some are multicellular. Some protists are very helpful. Some protists are very harmful. An example of a harmful one would be the protist that causes malaria, which can impact millions of people around the world. So the thing to keep in mind about malaria is we tend to associate malaria with mosquitoes. And while that's true, it's not the mosquito that makes you sick directly. It's the injection of the protist that the mosquito is carrying into you when the mosquito bites you. So the mosquito's got it, it bites you, it injects that protist into you, and that's how you get sick. So protists, lots of variety, lots of hodgepodge. Their reproduction is going to be mentioned in this video. Our textbook actually goes into the reproductive cycle of protists, and it's actually extremely complicated. So we're not going to touch on that, really. Same thing with the fungi, things I want you to remember about fungi. They are not plants, even though they kind of look like plants sometimes. But they do have something in common with plants. Their cells have cell walls. Now, something they have kind of the opposite of is that they are not autotrophic. They don't do photosynthesis, so they rely on other things for food. So while they have cell walls like plants, they cannot do photosynthesis. So think about other things about fungus. Sometimes they're helpful, like the antibiotic. Remember, penicillin was discovered in a lab by accident by Alexander Fleming. That was a mold that was growing, and a mold is a fungus. So the mold growing on that petri dish killed the bacteria, and that's how we came up with really our first antibiotic, penicillin. So helpful. Sometimes they're annoying. Sometimes they cause rashes on our bodies. So like athlete's foot is a fungus. Ringworm, fungus. Helpful, fungus. Yeast, bread rise. We like that. So good, bad, lots of things in between. That's going to be covered partly in this Amoeba Sisters video. Then you have this answer sheet down here to answer as you watch the Amoeba Sisters video. Now this video right here is a very short, one of the short ones I was talking about. It is showing you an amoeba eating a paramecium. Now the reason I want you to see that is because it talks about it up here. The Amoeba Sisters talk about themselves and how they eat. And they also talk about how they move, which involves how they eat as well. So when you watch the Amoeba Sisters video, they're going to show you that some protists move by a flagellum, some move by cilia, and Amoebas, as another example of a protist, have pseudopods. Pseudo means false, pod means foot. So they use a false foot, and you're going to see how this works. They have a cartoon drawing of it in their Amoeba Sisters video, but then this one is an actual it's filmed through a microscope. So you can see this amoeba using its pseudopod to engulf or surround the paramecium as it begins to eat it. So it's kind of cool, real short. Make sure you watch it though. Then in the Amoeba Sisters video, they talk about something called slime mold. Now slime mold is a confusing name because it has the word mold in it. Molds, true molds, are actually fungi, but slime mold is a protist. So it's a misnomer of sorts. It can be confusing. So a slime mold is actually a protist, but they're really cool. So I want you to watch this video. It's about 4.5 minutes, and there is a question set with it. But in this video, the narrator talks about this cool experiment that was done where the researchers did the study, and they took a map of Tokyo, Japan, and put nutrient spots on each of the subway stops throughout the city. And they put the slime mold on this map. And the really cool thing is that the slime mold stretched out and spread out to reach the nutrients. And they basically formed the subway map of the city. So that's really cool. And so that is discussed in this video. There's the question set for that video. But here is a short video showing you how that actually happened in the lab. So this one, the slime mold form a map of the Tokyo area railway system. There's no questions about that, but I do want you to watch it because it's pretty cool. Something else to keep in mind is these videos discuss millions, billions, years. They're taught from an evolutionary worldview. I don't want you to be discouraged by that. I don't want you to think I'm promoting that. What I do want you to come to grips with or understand is that that's the way society is framing all things. So we need to be able to hear that and then reframe it in our minds. What I would really want you to get out of this is a little bit of knowledge, but also a bit greater understanding and appreciation for the creativity of our Creator and how He could create all these things that many of which we will never ever see because they're still microscopic. And yet He's created them with all these individual traits and characteristics. So that's what I'm hoping you'll also get out of this. That's it for me today. I hope you learned something from the videos. I hope you enjoy the videos. And as always, I hope to see you soon. If you have any questions about how this assignment is supposed to go and I wasn't clear in this video, you can always shoot me a Google Classroom message or send me an email. Miss you guys. Talk to you soon.